I welcome you all in this workshop on Chemdraw organized by Department of Chemistry, MMEC MMGU Mulana. The source person is Dr. Pooja Sethi, Assistant Professor, Department of Chemistry, MMEC Mulana. Today, we'll learn about what is Chemdraw. Some of you might know about Chemdraw, might have heard about this, what is this, and some might not. So let's first learn what is Chemdraw. It is a drawing tool that allow the users to draw the chemical structures, reactions, as well as biological objects and pathways. It allow the users to use predict spectra, predict the properties and spectra, convert the chemical structures to high-tech names, view the 3D structures, etc. Now, you can see there are two type of icons over here. The first type of icon, it was first of all, the Chemdraw is a molecule editor first developed in 1985 by David A. Evans and Stewart Rubinstein, later by the chemi-informatics company Cambridge Soft. And the second icon appears because this Cambridge Soft company sold it to Perkin Elmer in 2012. Chemdraw along with Cam3D, CamFinder is a complete package and it is a part of Cam Office suite of the programs and is available for Microsoft Windows. Now, what are the features of Chemdraw? Let's see. It can convert the chemical structure to the name, chemical name to the structure conversion. It can predict NMR spectrum simulation. That means we can predict with the help of Chemdraw proton NMR as well as C13 NMR. It can also give idea about the mass spectrum simulation, structure cleanup, and there is an extensive collection of templates including style template for most major chemical journals are required. It can export to the PDF, but it is available for the Mac version only. These are the basic Chemdraw tools you can see over here. The Chemdraw tutorial overview. In this tutorial, we'll learn about the introduction of basic tool and their uses, how to draw or generate structures, how to draw structure from the names or smiles, how to evaluate the stereochemistry at a chiral center, basics of writing a reaction, the resonance, equilibrium, and basic reaction mechanism. Let's start with the session 1. Let's start the session. Now look at this. There are a few icons over here like file, edit, view, object. Let's go to file. There are document settings, layout, footer, drawing, caption, atom label or color. We can set in any format we want. Then there is open special. If I click on that, number of templates are available over here. You can set any template according to your requirement, according to journal requirement. As I have selected new ACS document 1996. Then there is edit view. Look in the view. There is 1, 2, 3, 4, 5, 6. There are 6 clicks you can see over here. If I unclick all these, uncheck all these, I'll show you what happened. Now this is clean window document. There are no crosshairs. If I click on show crosshairs, it will be crosshairs like that. If I'll check in show rulers, it is ruler on the top of this. Then show main tools. Main tools display on the left hand side. Then show journal tools. Journal tools are shown over here above the window. Show style toolbar. So there is style toolbar, subscript, superscript. Show object toolbar. Okay. So these will be according to our ease or according to our requirement. We can check or uncheck them. Okay. Now there is object. Next icon is object over here. Here is fixed length. Apply object settings. Okay. Fixed length, fixed angle. I'll show you later on. Then there is structure, text. In the text there is font, style, size, curve, color, and so on. Before starting, let me tell you about the tools. These are the tools. This is called lasso. Okay. If we'll write over here, anything we'll write over here. This is the text box. You can type anything over here, like methyl. Okay. And this is the lasso tool. It can be selected like that. Okay. And this is marquee. This also do the work of selection, right? Then there is mass fragmentation window. I'll tell you its use later on. This is eraser. If we want to erase this, just place it on the methyl and click. It will erase everything. This is the text box. If you want to write anything like CH3, okay. Then you've selected it and go on to CH3. Now look what we have done. Suppose COOH, okay, or if OOH, all will be in caps. Here it is CH3, okay, that should be capital. There is 3. It can be in subscript as well as in superscript. There are 2 options when you will select this 3. Okay, let's select it will be in, now it is CH3. When we have typed, 3 will appear in this mode. We want to make it subscript. Select this 3, go over here and click on this. It will now subscript. If we want to make some superscript value like A2 means A square, select this, go over superscript, click here and it will become A2. Okay, now this is solid bond notation. You can select this and it will draw solid bond will appear here. This is double bond, this is resonance bond, triple bond. So many variations are there. If I'll pick double bond, if we click over here, double bond will appear over here. Okay, this is dotted line. You can see dotted line if you require anywhere. This is wedge shaped. Hashed bond, bold bond, bold bond. This is wedge bond, follow wedge bond. Then this is wavy line. Let's select the wavy line. Then table tool. This is bond line notations. This is easy to draw. Look. You can draw it. It is easy. It will save our energy. Now there is cyclopropane ring. We can draw like that. Just pick it and click here. Okay. cycloheptane, chair form cyclohexane, this is cyclopentane, this is benzene ring over here. Okay, pen. You can draw it in any shape. Okay, then there are arrows, different kind of arrows. If you want to write mechanism, we can choose these arrows like that. Okay, here are resonance arrows for the arrow for reversible reaction, for resonance, for mechanism. If we want to write any mechanism, there are orbitals, orbital structure, hybrid orbitals. You can show like that. This is dz square. Okay, dx, dxy, dyz, dx square minus y square. We can draw any shapes from this. Let's draw this. Then if we want to look, this is very small over here, but if we want to increase the structure, we just select it. Look what I have done. I just go over and mark you. I have selected it, and there are two icons appear over here. One there is to rotate it, and here on the right hand side, right corner, let's drag it. You can increase its size as much as you can. Okay, now this is a window here, this is again for the writing of mechanisms. We use this bond line, dotted line, baby line, solid bond. Then suppose we have written some structure and we want to put it into bracket, shadow bracket, or we put into frame. We want to put it into frame, we can choose any of the frame like that. Okay, like this. Then there are brackets. It is square bracket, C bracket, and so on, single bracket, right? More signs are here, standard and all. Now look at this. It is, if we are writing mechanism, we can choose positive structure for the cation, plus sign, okay, dots, free radical to show the free radical, to show the lone pair, negative charge, and so single bond, wavy bond, and so on. So many options are there. This is TLC slide, and here so many templates available here, like amino acids. You can pick any amino acid. It will save our energy. You know, so many amino acids templates are there. Suppose we want to pick this, and just you can draw over here. Okay. Here are aromatics. So many structure of aromatics. Then bicyclic compounds. BioArt. Look at this in the BioArt. Lipid structure, bilayer structure of the membrane. We can draw this structure like that. Okay. Then BioArt, in the BioArt, let's DNA. You can draw the DNA like that. It will save your energy. So many options are available into this, like mitochondria, Golgi apparatus, right? Lysosome, clip art, like three-necked round bottom flask. We want to draw um, just condenser. Look, you can do anything with it. You can play with it also. So I'm just kidding. Not to play, I mean to say you can arrange in any position you require. These are the conformers, rings, cyclohexane, DNA templates, like there are sugars, adenine, guanine, cytosine, thymine. So there is base, deoxyribonucleotide, chain form and all. If we want to draw it in chain form of base over here. Functional groups are there, number of functional groups are there. Suppose we want to take this functional group, right? We can pick and choose, or we can click and put over here. Okay. Next, hexoses. These are carbohydrate structure sugars, pH rings, polyhedra. Then RNA templates, stereo centers, and supramolecules. A supramolecule, like this is a host-guest relationship. We usually study this. If we want to draw it, it can be drawn like that. Okay. This is all about the general introduction about the structures. Let's clean all that. We can clean all that. If we want to save it, we can save it also. But because it was general introduction, so it would better I should believe. Now I'll tell you about how to draw the structure. Okay. We can take templates. We can use structures from this place like cyclohexane, chair ring or benzene or anything, cyclobutane ring, cyclopropane ring, or these are bond line notations. Okay, let's start with cyclohexane. We'll take this cyclohexane. Okay, we want to draw the structure of toluene. Okay, now let's take for drawing the structure of toluene. Let's see. I'll go into structure. Firstly, I'll write the name of toluene. Suppose I don't know the structure, I'll write the name over here. I'll go, select it, go to the structure, convert the name to structure. Now look at this. This is the structure over here. Okay, or I can rotate it also according to my requirement. Okay, now I want to draw this structure by myself. Now what will I do? I'll take this bond, solid bond, go over this solid line and just click. Double bond will come here, double bond will come here, and double bond will be over here, right? Then there is one more bond over here. So I'll go at this corner. Look at this. This is the joint. Carbon, carbon, carbon. We all know that there are 6 carbon over here in the joints. I'll go at this. Now click over there. It will go in the upward position. Okay. We want to write. We can write here. It itself means that there is a methyl group, but for the more clarity, we can write here CH3. So it became methyl. Okay. Now, if we will select this and go to structure again, convert structure to the name. So its name is being displayed over here. You can do like that. Okay. Now we draw some more structures. This happens when we do not properly select a structure. Suppose it is benzoic acid, COOH. This is one way. Or the other way to draw this is copy and paste. Then copy paste is very easy method. It saves our energy. So I would prefer to draw again rather than to draw again, copy and paste. So if we want to expand this COOH, what will we do? There is a text box. I will write C. Now I can choose from here the functional groups. like that. Okay, this is one method. Or what we can do is, or otherwise, we can take a single bond, or click once more, it will be converted into double bond. Then I'll choose this text box, go over here and type O. Okay, since carbon has 4 bonds, carbon valency is 4, so it automatically completes its 4 valency by showing a hydrogen. If I do one one more bond over here, this H will automatically disappear. You can see, if I'll draw a bond over here, this hydrogen will automatically disappear. Now I want to draw over here one more oxygen, then I want to show a single bond, and then again text box H. Okay, this is the same structure over here. Now if I want to show the lone pair present on oxygen, so I can click over here. Look what I've done is, I've go over here, click this double bond, this lone pair. So look, this is appearing very minutely. So what can we do? We can enlarge it. Then pick it up and place it. So if we want to place one more, because oxygen contains 2 lone pairs, Control C, Control V, will drag this, then rotate it in this way in vertical form, and that we can do this. Is it okay? Now, if we want to magnify the structure, we want to increase the structure, we can do like that. If I want to reduce the structure, we can do like that. So many options available, like magnify, flip horizontal, I can flip it into this form. Okay, magnify, it will be magnified. Right. So I'll give you few structures. Let's draw the structure of aspirin. Okay, let's clean it. Draw the structure of aspirin. You try it yourself. Let's take text box and write here. Suppose we do not know the structure, how to draw aspirin. And aspirin. Select it. Go to object structure. Convert name to the structure. Aspirin cannot be generated. Structure cannot be generated. Few structures cannot be generated, but don't worry. Let's draw it. Then I'll choose a text box over here. Here is oxygen. There is ketone. Check one more bond. Select this double bond. Double bond over here. Then there is a single bond, and see, this is the structure of aspirin. Let's select it and convert the structure to name. 2-acetyl phenyl acetate, or the common name. Actually, we have typed the common name as pen. It usually takes the IUPAC names. So the IUPAC name is 2-acetyl phenyl acetate. So this is how we can draw the structure of benzene. Okay. Now let's take. I'll tell you one more feature. Let's deselect it. Suppose we are not choosing the structure from here, and we want to draw cyclohexane ourselves. We'll take this solid bond. I'll draw this. Okay. Suppose I cannot draw it properly. Then what we'll do? We'll select it. Go to the structure. There is an option clean up. Check structure. No errors found. Clean up structure. It will auto correct the structure, right? So again I'll show you. If I'll draw, I'll take this solid line. Okay, select it. I'll go to the structure and clean up structure. So it will convert like that. Actually bond was not properly drawn. So if I want to make it, I can make it like that. This is methyl cyclohexane. This is methyl cyclohexane. Okay. I told you about the subscript, superscript. Once more I want to tell you. If I have written here CH3, this 3 is in superscript. It can be in superscript. We can convert them into superscript, subscript. Features are here, X2, superscript is here. Or we can also change the font of the atoms. Like select it, right click. Now font. We click on the font. There are so many fonts available. Arial Unicode. Look, I want to write it in Times New Roman. So let's go to Times New Roman. It is Times New Roman. Okay. And again we'll click it. We want to increase the size, font size. It was in 10 because it is shown that it is in 10. Size is 10. Font size is 10. I want to convert it into 14 size. So to convert it to 14. Okay. Now, if we want to draw some reaction, okay, let's take this toluene. First, clean this. Take an arrow. Select this arrow, simple arrow. Okay. Then I want to add bromine into that. Br2. Sorry. Br2. Firstly, convert this 2 into superscript, or what we can do is superscript, or in the presence of iron. Right? What will we do? It will substitute at para position because it is ortho. This is para or ortho director. Select this toluene, copy and paste. Then go here. Just add bromine at the para position. Para bromo toluene. Okay. Now look at this. We'll select these bonds, bond line notation. Suppose we want to convert this into double bond. We'll select this double bond. Suppose we want to draw the stereochemistry wedge bond, or we want to show wedge and dash bonds. Let's select the hash wedge bond. Just go over here, wedge, solid wedge. Go over here. Look at this. If we click on this, object setting, bond position, topology. Okay, we'll go here in that view. Fixed length. I have already clicked on the fixed length and fixed angles. If I'm not clicking on the fixed length, now it can be dragged as long as it can be. So it would be better that go to object and fixed length. Select this option. So this will appear only like that. Okay. So we can write any text over here. It can be methyl or NH2. Then we can draw here hydrogen. Suppose this is an amino acid, or we have drawn a vague structure. Amino acid contains one methyl, one R group, one COH, one NH2, and one H. We want to see the stereochemistry of this. This is vague structure, not amino acid, but just like I have just drawn two functional groups which are present in amino acids, like carboxylic acid or amino. Okay. Now we want to see the stereochemistry. Show stereochemistry. You can see here it means there are two chiral carbons, but there is chiral carbon, it shows R, as well as because there is a double bond, so it show E, pentagon or Zussman structure, show these kinds of isomers also. Suppose let's select it, copy and paste. Sorry, again we'll do that. Copy and paste. Okay. Let's copy and paste. If I rotate this molecule, I'm going to flip horizontal, okay, then the stereochemistry has been changed. Oh, this molecule has been changed. I've drawn NH2. Let's do it again. This was the original molecule. Copy and paste. Now see the stereochemistry of it. We go to object and show stereochemistry. Okay. Now let's flip this molecule. Flip horizontal and now show the stereochemistry. Look at this. Now this structure, previously it was R, now it became stereochemistry changes. It is S, sinister. Okay, this is how we can show the stereochemistry of the molecules. One more thing, if we want to show the orbital structure or hybridization, or let's select the structure of, we want to know the structure of benzene, orbital structure of benzene. Okay, we'll draw in this form. Let's magnify this. Let's increase the structure and click on this orbitals. Okay. Orbital, draw orbital over here. Bonding, we want to show bonding in between them. Since we have fixed length, we have made the fix the length of, let's unclick it. Okay, and then do it again. Now in benzene there are 3 double bonds. Look at this, we can show like that. Let's clean up the structure. Clean up structure. Oh, it's cleaned. These red marks are because there is here the length width is more, here the width is less. That's why it is appearing. But with practice, we'll get to know. We'll draw it properly, and this red warnings will not appear. Let's do it again. Let's do it on ethylene. Okay, this is the ethylene. So this is all about the features. I want to tell you one more thing. Suppose there is some drugs of let's go to Google and type over here vancomycin smiles. So I'll go on the first option, PubChem. Here we can see, scrolling, there are smiles. Canonical smiles and isomeric smiles. Let's copy these smiles. Copy. Then go to our Chemdraw. Okay. Let's go to edit, paste special smiles. So this complicated structure will appear. So we can paste it like that. Okay. Right? Boom.